Well, hello, mathematicians. Welcome back. We're going to be talking today about dividing a fraction by an improper fraction or a mixed number. And I taught you to ask a question. How many of the fraction that we're dividing by are in the fraction that is being divided? And in this case, we have a situation where we have a smaller fraction, 1/2, being divided by an improper fraction, which means that it's more than 1. In fact, 7/3, if 3/3 is 1, and 2 3/3 would be 6/3, it's slightly more than 2. And if you think logically about it, there are going to be 2 halves in 1 and 4 halves in 2. And so a number that's a little bit more than 2, if we are asking ourselves how many of that number is in a half, it's going to be slightly less than a quarter. So logically, we can tell and make an estimation of about what our answer will be. And I'm going to say that practically speaking, our answer has to be slightly less than a quarter. So when we get into it, you'll see if I'm right on that one. And I also want to point out that we made a rule together. And the rule was when dividing fractions, we're going to be multiplying by the reciprocal. And we proved it again and again and again with tons of drawings. But now we're getting into numbers that are just too big to draw. And so we're going to be relying on the rule that we made for ourselves along the way as we were figuring out how to deal with these numbers as we're dividing fraction by fraction. Okay, so let's get started. What is the first thing I have to do? Well, I recognize that I am dividing 1/2. And I'm asking myself how many 7/3 are in 1/2. In order to do this, then I'm going to use the inverse operation of multiplication. And I'm going to take the inverse or reciprocal of the fraction. When I change the sign, I'm also changing up the fraction. Okay? So then all I have to do is multiply across. 1 times 3 is 3. And 2 times 7 is 14. So my answer is 3/14. Well, if you think about it, 3/12 would be a quarter. And 14ths are smaller than 12ths. So 3/14 is actually slightly less than a quarter. And I was right. So this is a reasonable answer, and that makes me very, very happy. All right, in order to check our work, we could come back and just multiply these pieces that we have. If we multiply them together, we should get 1/2. So let's try it. 7/3 times 3/14. We can simplify these. Oh, we can also simplify that. We get 7/14, which is 1/2. And that's what we started with. Okay, so I boxed in those 1/2, not because they're actually the answer to the problem. The answer to the problem is 3/14, but I just wanted to show you that if you multiply together, then you wind up with what you started with, which it's important in terms of checking your work. Okay, let's go on to another one. Let's try number 24 on page 74. Divide 5/9 by 4 1/3. Well, this is the first mixed number you've had to deal with. And we're going to do it together. So what do you think the first course of action should be? Is it easy to work with mixed numbers? No, it really isn't. And so the very first thing we want to do is turn the mixed number into an improper fraction. All right, so in this case, 4 1/3. So you have 4 wholes made out of third size pieces. So you multiply thirds times 4 wholes, and you get 12. And then you add your extra piece. Okay, so this is going to be 13 thirds. All right, and then we rewrite the problem. So it's 5/9 divided by 13 thirds. Notice that I have not kept 13 thirds is exactly 4 1/3. I have kept everything exactly the same. I haven't changed anything yet. Okay, so or yet. Here we go. Rewrite the problem. Okay. And then we're going to take what we're dividing, and instead we're going to use inverse operations, which is multiplication in this case, with an inverse number. Okay, so that's going to be 3/13. So step 3 would be multiply by the reciprocal. All right. Now, do you see anything that can be simplified? You sure do. And we're going to go ahead and do that because it's going to make our lives a lot easier. I see a 3 here. 3 goes into itself once, and it goes into 9 3 times. So now when I multiply across, numerator times numerator, I get 5 times 1, which is 5. And 3 times 13, which is 39. And this is our answer, 5/39. Now, remember a little while ago that in previous videos, that we were looking at the roots of how these problems work. I'm sorry, I still have a bit of a cold. And so we're just going to go ahead and run through what that problem would have been. It's 5/9 divided by 13 thirds. And we want to get rid of this complex fraction by multiplying by the reciprocal. And because we do it on the denominator, we have to do the same thing on the numerator, multiply by that reciprocal. So as not to change the value of the final answer. Okay, so we have here we can simplify like we did. It becomes the same problem. Okay, 5/39. It's just a matter of getting rid of this complicated denominator. That's where it all comes from. And you always show your answer in simplest form. Okay, let's do one more. Divide 2 3/5 by 1 8/9. Okay. What's the first step? What's the first thing we're going to do? Yeah, let's take care of these mixed numbers. Okay, we're still going to be dividing when we get done. The pieces in the first one are fifths, and there are 2 wholes. So fifths times 2 is 10, plus 3 pieces. So that's 13 of 5 pieces. And the piece size in the second one is ninths. There's 1 whole, so that's 9, plus 8 is 17 ninths. All right. And remember that when we're dividing, it makes it so much easier. Instead of having our problem be 13 fifths divided by 17 ninths, so much easier to get rid of this denominator by multiplying by the reciprocal. And when we turn this into 1 in the bottom, we need to do the same thing in the top to keep the value. So multiplying by that reciprocal. So 13 fifths going to be multiplied by 9/17. Okay. And we actually don't have any common factors that we can, factor out here. This is really one of those difficult problems that make you want to pull your hair out. All right, so 10 13s would be 130, so 9 13s are 117. And 5 times 10 is 50, 5 times 7 is 35, so it's 117 over 85. And I believe that works out to, let's see, 85 85ths plus, I don't know, maybe 32 85ths. You'll have to check my math. So this is 1 and 32 85ths. Not a very friendly answer, but an answer nonetheless. And 32 85ths, that's about, a third. 33 99ths, I think, would be about a third. So is this reasonable if 1 and a third I'm looking at? So is this reasonable? This is 1 and 8 ninths is almost 2, and 2 and 3 fifths is a little over 2. So are there about 1 and a third? 1 and 8 ninths in 2 and 2 fifths? Probably. Seems like it's reasonable. All right, check it. You can tell me whether I did well or not. Well, as a little bonus assignment, I'm going to give you a hands-on activity 7 on page 75 to do. I think that there's a lot of interesting stuff in it that you will like, the relationships there. You guys have done a great job hanging with me, and I hope that you have a great weekend. Bye.